Seeking English S.A.T. Workbook, page 440, problem 2, no calculator. This is a bad luck problem for me in terms of trying to make a video about it, but it's funny because it's one of my favorite problems to teach in class, and I hope by the end you'll understand both of those things. It says if, and there's this formula here, for all values of x does not equal 3 over b, where b is a constant, what is the value of b? And they gave you 4 answers for b. And usually I would say go ahead and plug them in a sensible order until you've eliminated 3 of them. This time I'm not going to say that. So this is an exception to exceptions. Okay, and it is interesting for that reason and for a related reason, which I'm going to show you here. Out of these 4 answers, one of them tells you a number that you should not plug in for x. One of them does, but we don't know which one because we don't have the answer. If we knew which thing not to plug in for x, we would already know the answer to this problem. So the best thing to do is assume that any of them could be the correct answer. And so there are 4 numbers that you do not want to plug in for x. And I'm going to explain in just a minute why this is actually pretty important. If you looked at these, if b were minus 9, then x would be minus 1 over 3, which probably you would never have a reason to plug in a problem that looks like this anyway. Okay, if b were minus 3, you would then have the number minus 1. You don't want to plug that in. Okay, if b were 3, your number would be 1, and you don't want to plug that in. Okay, and if b were 9, you'd have minus 1/3, which you also probably wouldn't have a reason to plug in most problems. So those are 4 numbers. One of these is a bad number to plug in, but we don't know which one it is, so we're not going to plug in any of those. But teacher, I know, I'm just making a complete list, but it matters for this reason. First number I would suggest to plug in for x is a 0, and I'm dealing with the x before the whole everything else. Okay, I know the denominators need to go away. There are other things we need to do. I'm dealing with the x first because if you don't get rid of that x, you're not going anywhere. Okay, it has to go away at some point. It's better to get rid of it quickly in the process. You can start making everything smaller and simpler for yourself if you can get rid of the x by plugging something in. Okay, as I said, you probably plug in a 0. I would suggest plugging in a 0 most of the time. Here, you can't do that because if you plug in 0 for x, okay, this here, it's not going to affect this. Okay, that would be really convenient. Okay, that would be a great, really convenient thing to plug in for those places. But if you plug in 0 for x here, then your b gets multiplied by 0. Okay, and then you're not really solving for b as a multiple of 0 because all multiples of 0 are the same. You won't be solving for b. You'll be fooling yourself and wasting your time. Okay, so next choice, always, I would suggest plugging in. If you can't plug in a 0, plug in the number 1. Why not? Wouldn't that be really convenient? Yes, it would. It would also create very little work for you in the numerators. Except that it's already on our list as something not to plug in. Okay, but teacher, there's 3 out of 4 chance that C is not the correct answer and that we could play. Don't play those odds. Don't do that, please. Okay, just move on to your next choices to plug numbers in. Okay, after 0 and 1, your next choices are the numbers 2 and minus 1. Now, in a problem that is superficially similar, minus 1 would be a great choice again because of this exponent here. Okay, this 36 wouldn't balloon out of control if you were able to keep it down to a 1 by multiplying the minus 1 in there. Okay, that sounds great, except that also it's on our list there. Okay, and again, there's a 3 out of 4 chance that wouldn't be. I know, but don't play those odds. It's a much more reliable and effective thing to just go to the next number. The next number is 2. My next choice would be 2. Okay. So what happens if we plug in a 2 here? This becomes. I'm gonna go through it pretty quickly. The order in which you plug them in and simplify them is up to you. Okay. Do it in a way that for you is reliable. Okay. I'm going to say this is 4 times 36. Okay. It becomes 144. Okay. That was that was 2 squared times 36. This one over here, 2 times 21 becomes 42. Okay. Over here it becomes minus 8. And down here it becomes 2b. 2b and 2b. Okay? Now, the order in which you next do things maybe doesn't matter that much. I just don't like to have a lot of characters on the page if I'm going to start moving things around. So if there are things that you can simplify right away, you may or may want to do that. I'm going to do it a little bit just because it says no calculator. Okay? And if you have a big pile of things to calculate at the end, and your brain is already tired, it depends on you, but in my case, more could go wrong. So this becomes 186 there, right? Yes, 186 minus 28 is going to become 158. I think that's right. 158. Okay, from there, this is minus 9. This is not my favorite brand of marker. It's very messy. Okay, here we go. There. So from there, now we want to get rid of these two denominators. It's a good trade to move one into a numerator up here to get rid of these two down here. So it's going to become minus 9 times 2b minus 3. Okay, and these denominators go away. I just multiplied everything by 2b minus 3. And from there, okay? So it's a little spaced out. The 31, I'm going to move over to the other side. It's a plus 31. Okay? And just to save myself some trouble in advance, it's going to become 189. There. From there, the minus 9 can come down here. You've got 2b minus 3 here. There. I'm gonna move the 3 over to the other side. 3 plus. That's a minus 3. And to get rid of this 2, I'm gonna divide everything over here by 2. So it becomes 3 over 2. And this becomes minus 18. Okay. And there we have b by itself. Now, you think nothing could still go wrong, but it could. And in a couple of previous takes of this video where there was a lot of noise, things did go wrong. So hopefully this is my last take. Okay. From there, to get a common denominator, I'm going to multiply top and bottom over here by minus 9. It's minus 18. And this becomes minus 27. Okay? Okay. So I don't need that. It's minus 27 plus... Actually stay minus 18. Okay. Minus 27 is going to become 162. Okay. And if you are not terribly fast at multiplication without a calculator, that's fine. Do whatever you need to get there. From there, though, it becomes this. First, I'll just cut it in half. It becomes 81 over minus 9, and from there. Hopefully it'll be more obvious to you. Do this minus 81. That's fair too. Divide both by 9, you get minus 9. Okay. And hopefully if you take the minus 9 and you feed it back through everything, that'll work out. Okay, so the number we should not have plugged in, okay, was minus 130. Would we have plugged that in? Probably not. But again, a major piece of value from this problem is understanding that if you don't know the correct answer, you can't know which number not to plug in. There are many numbers to plug in. Okay? If you had plugged in pi, it should have worked for this problem. It would have taken a long time. If you had plugged in square root of 2 for this problem, it should have worked. It should have just taken a long time. That's why I suggested first look at 0, we can't do that. And look at 1, we can't do that. Looking at 2 and minus 1, we can't do minus 1. That's why I selected 2. Okay? So if you think some other number is easier for you, if pi is easier for you in a similar problem, then use that. Again, it should work. My suggestion about looking at the smaller and simpler integers first is I think that works for almost every student. Almost every student.